Great day, my dear students. How are you? Do you miss having a class with your classmates? Or do you miss your lessons? The answer is here. We will bring to you our School on Air in Science 7. This episode will be streamed through radio, television, Facebook, and other online modes of learning. And I will be with you throughout this episode. Call me Teacher Dang from Villa Concepcion High School, Bacolod Extension. We are about to begin, so bring out your module and find a comfortable place. Check your speakers if you can hear me clearly and make sure that you can see me on your screen. Be sure to have your ball pen and notebook with you so you can write important information from the discussion later on. I am expecting that you will listen carefully, watch attentively, and of course, answer the questions diligently. Is everyone ready? That is good. We will now get down to our session. Today, we are going to start our lesson with a missing and electrifying adventure. Our topic is all about waves around you. After going through this module, you are expected to infer that waves carry energy and describe characteristics of sound using the concepts of wavelength, velocity, and amplitude. In this lesson, you are expected to answer and accomplish the following activities. For activity number 1, let's make waves. And for activity number 2, anatomy of a wave. And for activity number 3, mechanical versus electromagnetic waves. So without any further ado, let's get the ball rolling. Waves occur all around you in the physical world. When you throw a stone into a lake, water waves spread out from the splash. When you strum the strings of a guitar, sound waves carry the noise all around you. When you switch on a lamp, light waves flood the room. Water, sound, and light waves differ in important ways, but they all share the basic properties of wave motion. For instance, you can see water waves, and surfers would say that they enjoy riding the waves. On the other hand, you don't see sound waves and light waves, but you experience them in other ways. Your ears can detect sound waves, and your skin gets burned by ultraviolet waves if you stay under the sun for too long. But what is a wave? A wave is a periodic disturbance that moves away from a source and carries energy with it. For example, earthquake waves show us that the amount of energy carried by a wave can do work on objects by exerting forces that move objects from their original positions. In order to understand better our lesson for today, try to answer the following activities. Activity 1 will introduce you to different types of waves distinguished according to the direction of vibrations of particles with respect to the direction in which the waves travel. Your task is to observe and draw different types of waves and describe how they are produced. You will also describe the different types of waves. To do this activity, you will need the following materials: a rope at least 5 meters long and a colored ribbon. After doing the activity, draw 3 sketches of the rope, showing the motion of the pulse at 3 subsequent instances. Draw an arrow to represent the direction of the pulse motion. And answer the following questions. Letter A, what is the source of the wave pulse? B, describe the motion of your hand as you create the pulse. Letter C, describe the motion of the pulse with respect to the source. Letter D, does the wave transport the colored ribbon from its original position to the end of the rope? And letter E, describe the vibration of the colored ribbon. How does it move as waves pass by? Does it move in the same direction as the wave? A periodic wave can be regarded as a series of pulses. One pulse follows another in regular succession. Transverse waves occur when the individual particles or segments of a medium vibrate from side to side perpendicular to the direction in which the waves travel. Longitudinal waves occur when the individual particles of a medium vibrate back and forth in the direction in which the waves travel. Try to wave at your family member and observe the motion of your hand. Do you make a side-to-side motion with the palm of your hand? Do you do an up and down motion with your hand? The repetitive motion that you do with your hand while waving is called a vibration. A vibration causes wave motion. When you observe a wave, the source is always a vibration. Waving is a common gesture that people do to catch someone's attention or to convey a farewell. Congratulations, dear learners, for successfully answering all the questions in activity number 1 of your module. Now, let's proceed to the next activity. You had the experience of creating periodic waves in activity 1. In a periodic wave, one pulse follows another in regular succession. A certain waveform, the shape of individual waves, is repeated at regular intervals. Most periodic waves have sinusoidal waveforms as shown below. The highest point and lowest point of a wave are called the crest and the trough, respectively. The amplitude is the maximum displacement of a vibrating particle on either side of its normal position when the wave passes. In your activity 2, all you need to do is to identify the quantities used in describing periodic waves. By the way, learners, how can you measure the wavelength of a wave? The wavelength of a wave refers to the distance between any successive identical parts of the wave. For instance, the distance from one crest to the next is equal to one full wavelength. This time, place a basin filled with water on top of a level table. Wait for the water to become still. Create a vibration by regularly tapping the surface of the water with your index finger. Would you be able to see the subsequent crest of the water waves? After accomplishing it, try to answer the following. Draw the water waves as you see them from the top of the basin. Label one wavelength in your drawing. Increase the rate of the vibrations you create by tapping the surface of the water rapidly. What happens to the wavelength of the waves? Draw the water waves as you see them from the top of the basin. Compare it with your drawing in number 2. Congratulations, learners! You did it! The crest and trough refer to the highest point and lowest point of a wave pattern respectively. The amplitude of a wave is the maximum displacement of a particle of the medium on either side of its normal position when the wave passes. The frequency of periodic wave is the number of waves that pass a particular point for every 1 second, while the wavelength is the distance between adjacent crests and troughs. The period is the time required for one complete wave to pass a particular point. The speed of the wave refers to the distance the wave travels per unit time. It is related to the frequency of the wave and wavelength through the following equation. Wave speed is equal to frequency times wavelength. Now, for the last activity, which entitled Mechanical versus Electromagnetic Waves. In this activity, you will differentiate between mechanical waves and electromagnetic waves. But, what are mechanical waves? When you created waves using a rope in Activity 1, Part A, you were able to observe a moving pattern. In this case, the medium of wave propagation is the rope. The waves that you have created in Activity 1 all require a medium for wave propagation. They are called mechanical waves. All three kinds of waves, transverse, longitudinal, and surface, are sent out by an earthquake and can be detected by many thousands of kilometers away if the quake is a major one. By the way, what are electromagnetic waves? Energy from the sun reaches the earth through electromagnetic waves. As opposed to mechanical waves, electromagnetic waves require no material medium for their passage. Thus, they can pass through empty space. The electromagnetic spectrum shows the various types of electromagnetic waves, the range of their frequencies and wavelength. The wave speed of all electromagnetic waves is the same and equal to the speed of light, which is approximately equal to 300 million meters per second. In mechanical waves, some physical medium is being disturbed for the wave to propagate. A wave traveling on a string would not exist without the string. Sound waves could not travel through air if there were no air molecules. With mechanical waves, what we interpret as a wave corresponds to the propagation of a disturbance through a medium. On the other hand, electromagnetic waves do not require a medium to propagate. Some examples of electromagnetic waves are visible light, radio waves, television signals, and X-rays. Now, try to answer the following questions from activity number 3. For number 1, how can you generate mechanical waves? For number 2, what do you think is the source of earthquake waves? And number 3, what is the medium of propagation of earthquake waves? With that said, my dear learners, I hope you are now ready to answer all the activities in your module. I hope that you have learned new knowledge and skills in this episode. If you want to deepen your skills about waves, just refer to the different additional activities of your module. For further inquiries and clarifications, feel free to send me a message via any means you can access. In addition, boxes are installed in your schools where you can drop your output for checking. Always remember to abide our community rules against coronavirus because it is better to be safe than regret. Once again, I am Teacher Roda Barut, emphasizing the phrase, we learn as one, we heal as one.